Okay guys, so we're going to be working those problems from the board, and one thing I want to stress is that this is golden. You know all your derivatives, and this is just showing how you can work backwards now. So if the derivative of cosine is negative sine, then when you work backwards to do the integral of sine, it goes to cosine. But that negative that was there had to also go to the other side. So if you think about it a little bit, I think it's going to make a lot of sense. Derivative of tangent is secant squared, so the integral of secant squared is tangent, of course, plus c. So here's a list of some that pop up quite often that you need to know. You shouldn't have to memorize them because you already know the derivatives. You're just going to be working backwards, okay? We're going to be using all of these to do the problems that were on the board in class. So the first one, a lot of you, we already did together, but the problem is that we don't have a quotient rule or product rule for integrals that you know of. So for now, what we have to do is if we see a problem, we actually just want, we actually just want to have only terms separated by plus and minus. So the way to do that for a problem like this is to, since you have a monomial down here, is to rewrite it first such that the 2x goes with everybody. So I'm just splitting it up here. And then you can reduce. So when you reduce this term right here, it's going to turn into an x squared. The middle term, this x will cancel with one of these, so we will have 3/2 x. And then at the back, the x's are gone, and we just have a 2. Now, this is our new problem, and this is what we're going to integrate. So I'm going to take the first term, and I'm going to add 1 to it and stick it over 3. Minus, this 3/2 right here, this is a coefficient, so you can think of it as being in front of the integral. So I'm just going to recopy the 3/2 and then figure out what the integral of x is. So right now, x is to the first power. So it's going to become an x squared over 2. So these are multiplied right now. And then the integral of a constant is just 2x, and of course plus c. So clean it up if you can. And the only thing I can really clean up here would be, I've got 3/4 x squared plus 2x plus c. So that's going to be it for me. So that's my final answer for the first one, okay? The second one is not that. Okay, the second one looks something like this, 3 square root of x dx, okay? Once again, a coefficient, don't let that bring you down. In fact, if you want to write the coefficient in front of the integrand, you can, and that might help out a little bit. I don't like square roots, so I'm going to recopy it again and call that x to the 1/2. Now I'm going to take an integral of this, and when I do, I'm going to add 1 to the exponent, so it'll become x to the 3/2, and it's all over 3/2 plus c, and you've got this mess to clean up, okay? Well, currently this 3 is a whole number, so you can put it over 1, and instead of dividing by 3/2, we can think of that as multiplying by 2/3. And then I've got my x to the 3/2. So when you look at it like that, it just becomes 2x to the 3/2 plus c. Oops, and that 3/2 is terrible. It really should be more like an exponent, okay? Exponent, okay. So there's your second one, and that would be my final answer for that. Okay, the next problem on the board was the integral of 7 over 3 x squared dx. Same thing, I always look for coefficients first and forget about them. Bring them out to the front and forget about them. So 7 over 3, I'm pulling to the front, and that leaves me with 1 over x squared. Okay, well, I don't have a rule for this as is, but I can rewrite this as the integral of x to the -2nd dx. So it's just like derivatives, guys. You can't take a derivative of this in this form. You can't take an integral of this in this form. You've got to rewrite it first. And now I can add 1 to -2, and when I add 1 to that, it's going to become x to the -1st, and then over a -1. and then plus c. So to rewrite this, it looks like this negative 1 times the 7/3. This is just going to make for a negative 7/3. And then x to the negative 1 just means that the x is going to end up in the denominator. So that would be my final answer for number 3. Okay, the next one is the integral of 3 square root x minus the cubed root of x to the, I can't see it, I think that's a squared, and then plus 1 dx. Okay, so if this is the problem we're dealing with, there are minus and plus signs between these, so you can totally split it up and do each one separately. But first I'm going to rewrite it. So this is this. This one I'm going to rewrite. There's a rule where you can rewrite it as an exponent. Hopefully everybody remembers that. And so this is my problem. It's all of this with respect to x. So integral of each part. So for this one, I'm going to add 1 to my exponent. And so I'm going to have 3x to the 3 halves. Now it's over 3 halves. So I can either write over 3 halves, or I can go ahead and do the reciprocal and call that a times 2/3. And that's what I'm going to start doing for the rest of this video. I don't like putting a fraction in the bottom. I'm going to go ahead and flip it right off the bat, okay? Minus, for this one, if I add 1 to 2/3, that becomes 5/3. And instead of putting this over 5/3, I'm going to multiply by 3/5. And there is no integral sign anymore, sorry about that. Plus, the integral of 1 is just an x plus a c. Now, if any of this simplifies, simplify it, otherwise you're done. This, I'm done, I'm done, I'm done. Right here, though, these 3's can cancel. So it looks like final answer 2x to the 3 halves minus 3/5, x to the 5/3, and then plus x plus c. So I would write my final answer like that. All right, now we move to stage 2. So the other side of the board had the stage 2 problems. These aren't necessarily more difficult, it's just that you can't use a power rule on every single one of these, okay? So the first one up there says 3 cosine of x plus x squared with respect to x. Okay, now this we're going to power rule just like normal. This one we cannot. Now the 3, though, you can imagine as being in front of the integrand. And we're going to do another integral of this one. So we're splitting it up because of the plus sign. So right here, I just recopy my 3. And then the integral of cosine is a positive sign. Okay? Plus, power rule this just like before. And then plus c. That's it. The next one was, if I can read it, this one's going to trip a lot of people up. I'm going to promise you this is going to show up on a quiz or test in the very near future. You got to be able to do this. You don't have a power rule for multiplying these two, okay? So since there's no power rule, please don't just take each one separate. You want to rewrite it first. So I would rewrite it as x, and then it's times x to the 1/2, okay? That's what we're looking at. Remember, this has a power of 1 on it, and if you have the same base, it's totally legal, and actually, it's the only way to do this problem if you combine them. And when you combine them, you add their exponents. So that's just a rule from Algebra 1, 2, and Pre-Cal. We add those fractions together and get a 3/2, and now you're ready to integrate. So to take the integral of this, I'm going to add 1 to the power, which will become a 5/2. Instead of putting it over 5/2, I'm going to go ahead and flip it and call it a 2/5. And that is my answer for that one. The third one in the list was the integral of, it looks like 1 over x minus the sine of x. And so this one is probably going to trick more people than anything else. You are going to be very tempted to do a power rule. But if you rewrite this as x to the negative 1, and then you try to do a power rule on it, and you do plus 1, that's going to make a 0, which is going to make the whole answer to the problem undefined, because you're going to have x to the 0 over 0, which means 1 over 0, and that just doesn't exist. So you can't do a power rule. And what do we do instead? Well, we have to remember that there was a derivative who had, the derivative of natural log had an answer of 1 over x. And so because of that, we're working backwards. So the integral of 1 over x is just going to be the natural log of x minus the integral of sine, which the integral of sine, let me erase that integrand, I did not want that. The integral of sine is actually a negative cosine x, and then plus c. So to clean that up, we're going to do natural log of x plus the cosine of x plus c. Now, you're going to learn in class why we're going to be putting absolute value bars around it, but for now, just trust me and put the absolute value bars around it, okay? All right, so our next problem, or I guess it's our last problem, is this one right here, the integral of 5e to the x plus secant squared of x dx. Okay, can't power rule because these are not looking like x to the n at all. So you can't use a power rule. So you got to know your derivatives and be able to work them backwards. That 5 is a coefficient, so I'm really going to think of it like that. And I'm going to split this integral up into 2 parts in my mind so that I can, because of the plus sign, so I can think of them separately. So the integral of e to the x is just e to the x. And the integral of secant squared, you have to know your derivatives well enough to work backwards. And I know that the derivative of tangent is equal to secant squared. So because of that, if I need the integral of secant squared, it's going to be tangent. And then plus c. And that's all she wrote. There's all your answers. And go ahead and watch that next video if you haven't already. Thank you.